Okay, so to follow up ANOVAs, we want to look at multiple comparison procedures because that's where they come in. So we just saw that one of the shortcomings of the ANOVA is that although it's great for telling us when we have three or more groups that there is a difference, if we do have a significant F-test, if there is a difference among three or more groups, the shortcoming is we don't know where that difference or if there's difference among all the groups or if it's just between a few specific few. So how do we spot these specific differences? It might be tempting to think, well, what if we do an ANOVA, then we just compare those individual groups, almost like doing t-tests between these individual groups. Well, there would be an issue with that because that is the same problem we started with. We can't just do a bunch of little individual t-tests without worrying about that type 1 error inflation. So go back to that Russian roulette example of how every time we do a bunch of individual t-tests, we're really increasing the likelihood that we run into this false positive. So that's why we came up with this ANOVA in the first place, because it was an ideal solution to do one test instead of three or more little ones, and maintain just a safe error rate, type 1 error rate. So MCPs are used. MCPs meaning multiple comparison procedures, as the name implies. Uh, if you have three or more groups and you have an ANOVA type situation like we've been detailing, then if you want to look at specific pairs of groups, you have to consider about that type 1 error inflation. So MCPs are simply corrections for those individual comparisons. So they essentially allow you to do an ANOVA and compare the individual groups that you need to. Depending on the MCP you use, you can make some very specific comparisons, or you can just compare all possible pairwise comparisons. So, of the different multiple comparison procedures, they all make some sort of correction. They just differ in how they make those corrections. So, for instance, you covered Fisher's. That correction essentially just makes a correction on how T is calculated when you follow up ANOVAs. So you do an ANOVA and then you do these pairwise t-tests, but Fisher makes a correction on how that t is calculated. Bonferroni and then Holmes, they're very similar. The corrections they use are placed on the alpha, or if you want to think about it, they sort of correct how p is calculated as opposed to a t or for anything. What you really need to know about MCPs is what the goal of the correction is. So Fisher's goal would be to make some correction to T, Bonferroni and Holmes, so some correction to alpha or P in another way of thinking of it. So you won't have to know how to calculate those corrections, how to actually implement those corrections, but know what their goal was, where that correction is done, but most importantly, be familiar with what they look like. So for instance, in your lab, you've done the one way ANOVA, then you followed it up with some multiple comparison procedures. Be familiar with the output you got from those. So go back and look up your lab lectures on how to do those and be familiar with what they look like and how to make those comparisons yourself.